Hello everyone, good day. Today, I will compare NiMH batteries and lithium-ion batteries from multiple perspectives. This analysis comprises 6 independent and fully comprehensive modules. Let's take a look together. In this chapter, we'll start by looking at the differences in battery structures. The all-new nickel metal hydride battery pack utilizes Toyota's proven 2.5 generation 6L series technology, eliminating the need for an additional balancing board and allowing for direct compatibility with the original factory system. In contrast, the ternary lithium battery pack consists of only 2 cells connected in series. Its simple balancing board is incompatible with the vehicle's BMS control system, making it difficult to manage during high current charging and discharging or on long downhill gradients. This poses a risk of thermal runaway and explosion, and the quality of used cells cannot be guaranteed. Translated with dpel.com free version. Next, we'll compare them using concrete data based on their core performance metrics. Nickel metal hydride NiMH batteries are aqueous batteries that offer a long cycle life, wide operating temperature range, and a discharge rate of up to 70 C. They can be charged to a maximum voltage of 9.6 volts. In contrast, ternary lithium batteries use an organic electrolyte, have a short cycle life, poor consistency, and poor low temperature performance. Their discharge rate is limited, and they can only be charged to a maximum of 8.4 volts. Overvoltage causes them to malfunction. Therefore, NiMH batteries are the more reliable choice. Next, we'll take a closer look at how the two batteries compare in terms of safety performance. Nickel metal hydride batteries use a non-flammable aqueous solution, eliminating the risk of combustion at its source. They have passed extreme tests such as short circuit, puncture, and incineration tests, remain stable at temperatures as high as 120 C, and remain set. The voltage drops to 0 volts, with no risk of explosion or spontaneous combustion. Safety is embedded in their very design. Ternary lithium-ion batteries pose inherent safety risks. Mechanical impacts such as short circuits and puncture can directly trigger rapid combustion, leading to irreversible thermal runaway, which can cause an explosion once the temperature reaches 150 C. Over-discharge can generate copper dendrites that penetrate the separator, causing an internal short circuit and releasing toxic hydrogen fluoride, ultimately resulting in catastrophic accidents involving the entire vehicle. Catching fire. The maximum temperature rise of nickel metal hydride NiMH batteries is kept below 50 C, with a system temperature difference of only 3.5 C, eliminating the risk of thermal runaway. In contrast, ternary lithium-ion batteries can experience temperature rises of up to 100 C, with a system temperature difference as high as 10 C, posing a very high risk of thermal runaway. Clearly, the safety advantages of NiMH batteries are evident. Toyota's original BMS for hybrid vehicles is specifically designed for nickel metal hydride batteries, yet its compatibility logic fundamentally conflicts with the charge-discharge characteristics of lithium-ion batteries. This constitutes the core contradiction. Modifying lithium batteries only addresses software-level compatibility issues in the BMS system without adding hardware safeguards, making them highly susceptible to overcharging. The accompanying IC chip merely performs passive identity verification, lacking any capability for current control protection. It will inevitably lead to internal short circuits and thermal runaway fires. NiMH batteries have far greater tolerance to overcharging than ternary lithium batteries. Even when overcharged to 10 volts, they do not catch fire, their temperature rise remains controllable, and there is no risk of lithium dendrite formation. In contrast, when ternary lithium batteries are used in Toyota's hybrid system, the charging logic is incompatible, making them highly prone to overcharging on long downhill slopes. Just 10 minutes of overvoltage can cause them to catch fire, and lithium dendrites can pierce the separator, directly leading to safety incidents. The safety differences between the two are night and day. We conducted comparative tests, simulating the real-world conditions of energy recovery on long downhill slopes in a Toyota hybrid vehicle. The nickel metal hydride battery showed no abnormalities even when overcharged to 10 volts, with only a slight increase in surface temperature. In contrast, the ternary lithium battery began to smoke and catch fire after just 10 minutes of being overcharged to 8.5 volts, while also releasing large amounts of toxic gas. The safety of the two battery types was tested by subjecting them to continuous charging at a high current of 128. The nickel metal hydride battery withstood the test for the full 3 minutes, exhibiting only slight surface warming throughout. In contrast, the ternary lithium battery exploded after just 1 minute and 13 seconds, clearly demonstrating the difference in safety. Next, let's take a look at how these two types of batteries actually perform in high-end, low-temperature environments. Nickel metal hydride NiMH batteries offer far superior thermal stability compared to ternary lithium batteries. Their temperature rise remains controllable even under extreme operating conditions, with thermal runaway only triggered at 300 C, ensuring ample safety margins. In contrast, high temperatures accelerate performance degradation in lithium batteries and cause them to release toxic gases. They are also more prone to spontaneous combustion and explosions. During prolonged overcharging or high-rate discharge, choosing NiMH batteries means choosing reliable safety assurance in high-temper environments. Nickel metal hydride batteries are capable of operating at extremely low temperatures, as low as -40 C, delivering stable power output during cold starts and covering a wide temperature range from -4.5 C to 60 C. Lithium-ion batteries experience a significant drop in performance at 0C, making them unsuitable for use in cold climates. This leads to a sharp increase in internal resistance and higher fuel consumption, and charging at low temperatures poses a critical safety risk due to lithium dendrite short circuits. Next, let's take a look at the differences in fuel consumption and service life. Nickel metal hydride batteries have a long cycle life and low degradation, whereas ternary lithium batteries have a short cycle life and poor consistency. Their degradation accelerates under fast charging, fast discharging, and high voltage conditions, resulting in an extremely short actual service life. The ternary lithium-ion battery packs currently available on the market are all used batteries, salvaged from vehicles. They suffer from poor consistency, short service life, and rapid degradation, resulting in actual fuel consumption that is 1.52 liters per 100 kilometers, higher than that of nickel metal hydride batteries. In contrast, nickel metal hydride batteries are brand new products that offer stable performance and a long service life. Next, I'd like to share some tips on how to choose products that offer great value for money. Nickel metal hydride batteries are a proven alternative, offering a long service life, low energy consumption, and virtually zero safety risks, with a payback period of just 3 to 5 years. Ternary lithium batteries, on the other hand, are extremely inexpensive to purchase but lack technical support, degrade rapidly, have a short lifespan, consume more energy, and pose a risk of spontaneous combustion and explosion. Therefore, safety is the core criterion when selecting a battery for a hybrid vehicle. Nickel metal hydride batteries offer excellent performance at low temperatures and pose no risk of thermal runaway, making safety their greatest asset. In contrast, lithium-ion batteries suffer from critical issues such as system incompatibility, inadequate protection, thermal runaway at high temperatures, and failure at low temperatures. Therefore, it is essential to choose products that are safe and reliable. Friends, as the data above shows, lithium-ion batteries are inexpensive but consist entirely of used batteries salvaged from scrapped vehicles. They pose a risk of spontaneous combustion and explosion, and their safety cannot be guaranteed. In contrast, nickel metal hydride batteries offer excellent low-temperature performance, carry no risk of spontaneous combustion or explosion, and have a long service life. Safety is paramount. Don't drive around with a ticking time bomb in your car.